again. So we're gonna get started. Today is the last class for the Python for Data Science bootcamp, and it's been a very interesting and challenging series. I am for most especially for people that are just getting started with Python and data analysis, data science as a whole. So I want to commend your efforts. I want to commend your tenacity, coming this far. It takes lots of, lots of effort, right? Not to get a lot of people started, we all started together and we noticed that there were a lot of people that were just dropping by the way. But I want to encourage everyone and say well done and keep up the good work. So today we'll be doing the final wrap up of what we've been doing over the past 7 classes. So today is class 8 for the Python for Data Science bootcamp training. So we'll be doing a wrap up, and as we are wrapping up, I'll be sharing what we'll be doing, the next steps, and I'll be sharing with you all also. I didn't touch on data visualization because of our time, but in the course of showing you the project, I'll be sharing some parts on data visualization, so that because it's also very, very key, it's very, very important in Python for data science package. So we have the Seaborn package, Matplotlib package, and Plotly package. So I'm going to touch on Seaborn briefly and Plotly. All right, and it's very it's not so difficult, but it's just for you to try to follow through as I take you through it. I'll take you through the basics, and then you can always learn more as we go on. All right. Okay, so we're going to get started. So if you go to the classroom, the LMS, you would notice that there was a pandas review challenge from last class. I said you should try your hands on this challenge. Please try your hands on the challenge. It's going to help you to further firm up your knowledge on pandas. All we've covered from the beginning of pandas package up to this time. It's going to firm up all the basic skills that you need, for pandas. All right. So I just thought to mention that you can also find it under the class, the recordings. You'll find it there, and then you submit the challenge. It's self-graded, but then you can submit the exercise. Okay, so data visualization with Seaborn. I'm going to mention a little bit on it quickly, and then I'll go into the projects, what we are supposed to do with our project. Then I'll show you a walkthrough on how to go about your projects, and also with respect to the submission and all of that. Okay, and other details. All right, so Seaborn is a library for making statistical graphics in Python. We have other packages like Matplotlib. It's built on top of Matplotlib, and they are closely integrated with Pandas data structure. So, in the course of your data science journey or your data analysis journey, you'll be doing a lot of visualizations. Like part of analysis is to also visualize your data sets. You want to ensure that your users, they have like a graphical concept of all the investigations you've made on your data set. So that's part of the essence of visualization. There is a saying that says a picture is worth more than 1,000 words. No matter how much you have done several analysis, when you show it in form of visualization, it makes a lot of, it makes the story more interesting. And so that's part of why visualization is very, very key. So I'm going to let me open the notebook where I have the Seaborn package. Okay, no, this is not it. Let me bring it up. Okay, I just want to bring up the notebook. Okay, I'll just touch on little basics on Seaborn because of our time. We have so much to get done today with respect to the project because that is very, very key. I need to, take you through how to go about if you're given a task to solve a real life problem, how do you address it? How do you attack such task? All right. So, like I said about Seaborn, it's also a Python package for visualization. So we have so many visualization packages. We have the Seaborn, we have the Matplotlib, we have PyPlot, we have the Plotsy. Plotsy is so interesting. I like Plotsy so much, but if you was just starting, it's very, very it has a lot of intricacies to it. So that's why I just want to take you through the basics of Seaborn. So if you're using Plotly, you can also, the good thing about Plotly is that you can integrate Seaborn into Plotly and Matplotlib as well. So it's a very, very good visualization package. And you can see all the charts that you can display with the Plotly package. But let's just go through Seaborn for a start. All right. So like other packages in Python, the first step is to install. If it's not installed, you pip install Seaborn on your command prompts. On the Anaconda prompts, you can open a new Anaconda prompt and then you just pip install Seaborn. If it's installed properly, when you load this import. Oh, okay, you're not seeing my screen. All right, so which screen am I showing? Let me check. Oh, sorry, I don't know what went wrong. Let me just reshare it then. Okay, thank you for that. All right, so like I was saying earlier that I went to Plotty website. This is a website, and I was saying that it's also a very robust package for visualization. And basically, these packages are very easy to use so long as you know how to read documentation. If you know how to read documentation, it should be very it's very easy to implement. You just take a cue from the documentation. I'll show you an example. All right, so you just take a cue from the documentation and then try to replicate maybe some of their examples. So let me just go through Seaborn first before I show you a bit about Plotly. So I was saying that Seaborn is a package, a Python visualization package, and it's used to make statistical graphics. When you're doing your analysis, most times before you actually go to get to building machine learning models for people that want to go into core data science and machine learning, you have to first of all explore your data. You need to analyze your data set. You want to find out what are the relationships between different columns in the data set with respect to what you're trying to predict when you're dealing with a machine learning task, or what are the insights in that you can gather from the data set using the visualization. So that's part of the goal of visualization. You just want to find out relationships. You want to find out different stories with respect to your data set. Additionally, for people that want to go into core data analysis, right? You also want to use visualization to tell for data storytelling. You want to you want to use it to create dashboards. So this package is Seaborn Matplotlib, when you want to use them for the dashboard creation, you have to use it with another visualization tool, like in terms of a front-end display tool like Streamlit. All right. So it doesn't stand alone. You can't just use it for creation of dashboards. So that's you basically use it within your projects just to visualize your data sets, and then you gather insights from it, and you're able to share your report from that from it. But if you want to do visualization, like core visualization, that's why you learn tools like Power BI, Tableau. That would help you, to create very, very powerful dashboard. But however, there are several improvements with the era of ChatGPT, OpenAI. Find out that like some packages, like there's this package called Pandas AI. Maybe during one of our community master classes would be sharing what Pandas AI does. It's a very, very powerful OpenAI package. All these codes you're writing, you can just chat, and it helps you to chat with your data sets. You can just chat with your data sets, and instead of you writing queries, you can use a chat to chat with your data set, and then it returns the results based on your chat. It helps you to also plot graphs and all of that. We have several other data sets as well. Okay, for this particular data set I'm working on, it's on the LMS, this notebook. This is the notebook. Oh, okay, the data set is not on the notebook, right? Okay, this data set is not on the LMS. Okay, I would attach it to the LMS. I don't know if I can share it from here, but then I can just attach it for additional reference. Okay, so when you're faced with a visualization task, the first thing is to, after having loaded your libraries, and then when you're importing a Seaborn, you import Seaborn as SNS, then I want to use pandas here, so I'm also importing pandas as well. So import Seaborn as SNS, and then you can load. There are different templates. You can use this. There are different themes you can use when you're plotting your graph. So you can just use sns.set to set the theme for your graph. I'll explain what that means when I move, like all this background. It's because I didn't set any theme. I'm just using the default theme. But if I want to set additional theme, I can just set it under this theme. I can just put they can use black grid, white grid, or whatever grid you want, right? But that's not where we're actually focusing on now. Let me just go straight to the analysis and different type of charts. So for example, you are working with an external data set, you read your data set using pandas read.csv. Yeah, so having read it, you can check the edge to look at your data set and all of that. All right, so in analysis, to plot graphs, you have to really understand what graph is good for what. Where do you use a particular graph? What type of graph suits the kind of data that you're working with. So we have different type of data, right? We have the numerical data, we have ordinal data, we have categorical data. So like this population table now, this is just like just in normal data, numerical data sets, right? So you could have like the states, Abia State, Adamawa, Akwa Ibom, they are categorical data set, like because they have different classes, category. When you're dealing with classes, that's a categorical data set, then categorical column rather. Then this is like a normal numerical column. So for a dist plot, SNS has a dist plot function where you can plot the distribution across a numerical column. For example, you want to see the distribution of, maybe you're having prices, you're having population, you want to see the distribution of that particular plot. If you want to read further, you could just go down and you read further about this function. It says that it's a flexible plot, a univariate distribution of observation. So it shows you the way your data is actually distributed. So we have different type of distribution. We have the normal distribution. We have the left skewed and the right skewed distribution. So this, when you are in the machine learning class, right, I'll take you through some basic statistical terms, what you mean by normal distribution, left skewed, right, because that all those type of, you need to understand the kind of data you're working with when you are dealing with, when you have to make predictions of models and, and perform such operations. All right. So, but then for normal distribution data, it shows you that your data set is evenly distributed, right? That is that the mean of the data set, they aggregate towards the center. For example, you could have a numerical data, a numerical column, right, of age, the ages of people between maybe 12 to 40. And within that column, and maybe you might be dealing with like 1,000 records. But within that column, if you plot your dist plot, if you plot your dist plot, you find out, you can, and you find out that your data set is looking like a bell-shaped format. It tells you something. It tells you that the aggregate, the median value of everybody within that data set is at the middle. That is the age the distribution of the data. You can have the data set between the ages of 12 and 50, but then it's telling you that the distribution of the most people are within the ages of let's say 20 to 30 years old within that data set. That's what a normal distribution tells you. It tells you that most people in that population have their median value aggregated towards the center. So with this plot, you can easily see the shape of your data with respect to the population. So in this data set, we are saying that if we do .info, right, you can see a little bit information about the data set. Okay, this data set is just very small. We have just the area and the population, 37 records within that data set, but then it's telling you the distribution of the data set. So we have some default data sets in Seaborn that you can easily use. If you go to the Seaborn website, Seaborn documentation, if you go to the Seaborn website and go to tutorials, now if you really want to know more about Seaborn, you can come here to study. This is the documentation, right? It's going to take you through introduction, examples, and all of that. So there are some default data sets that we have in Seaborn. We have the TIPS data set. TIPS data set is like a data set of a data set of a tip. Let me show you. Let me visualize the data set so that you can see what it looks like. Sorry, I'm trying to okay. All right. Let me load the tips data sets. All right, okay, this is it. So this tips data set, what it holds the data set of some set of people that actually maybe they've gone like a dinner or a restaurant data set whereby they're gathering the data of the people when what time what time they are eating, the time that they eat. Is it dinner? Is it lunch? Is it breakfast? Did they tip the waitress or not? The total bill that they actually paid for that meal. So this is just this dummy data set that can teach you a bit about visualization using Seaborn or any other. You can use it with any other data, with any other visualization package, but this is just like a sample. So if you have this kind of data set, right, let me check the information about the data set. Okay, we have like 244 entries, right? And then we have 7 rows. Okay, so if you do a dist plot here, you can see the distribution of this is not normal. It's left skewed. These are left skewed data because the tail is towards the right. So, and the orange is towards the left. So it's a left skewed data. It's telling you that most the size of that data set is tilting towards 0. This is where the majority of the sizes are. All right. So that is what this plot tells you. So you can also do other plots, like let me show you the joint plot. So the joint plot is a plot that helps you it makes comparison between 2 numeric features. This is total bill and tips. Look at the total bill column. You can see what the total bill column looks like. It's a numerical column. Then the tip column is also a numerical column. These other columns are categorical column, female, male. They are just 2 categories. Smoker, you can use your value count to check. Sorry. Smoker. Okay, so you can see that smoker is yes or no. We have 2 categories on that smoker. We can also find out the categories on the time. Okay, it's just dinner or lunch. So with this, these are categorical data, but then when you're doing a joint plot, you plot it against 2 numerical data sets. And what it does is that it shows you it gives you a scatter plot of the relationship between those 2 numerical data, between tip and total bill. What is the relationship? You can see that it's telling you that there is a positive relationship. When you see that the plots or the dots are tilted towards a straight line, it's like a positive correlation between the 2 numerical data. And even here, it even tells you the per person correlation. You can see that it's 0.68. Correlation is between negative to positive. So if you have negative, the minus 0, minus 1, you find out that that is a very, very strongly correlated data. It's most times the shape of that data looks like this. It's slant like this, as if you're drawing kind of what's the shape of this, like this triangle. Yes, the right angle triangle. That's the shape of that particular negative correlation. But a positive correlation, you have more of the dots towards the origin of your data, of your graph. So this shows you if there is a strong relationship tip and total bill. That is, as the total bill is increasing, then it's possible that people give higher tips. That's the way to interpret it when you have a positive correlation. If the correlation is actually 1, that's when you have a very strong correlation. All right, so it tells you that, oh, probably if this is a very positive straight line, it's telling you that, okay, the relation between total bill and tip is that as the total bill is increasing, then you can say that, oh, the tip, like here, you see that the total bill is about 50. The person is giving like 10 maybe dollars tip. You see, but here you can see that the total bill is actually like 0. The person is giving like zero tip. So this is like a positive correlation. So that's what the joint plot does for you. And then it also plots a small bar charts here, showing you as well the distribution of individual, the total bill, and then the tip data. All right, so the joint plots, we have other kinds of joint plot. We can have the scatter plots, has the kind, or you can use your kind as X if you want it to show you something like a color code difference. You can see that this is also a kind of plot. This is the same thing, but it's just like the design is different. So that's just the difference between the two. Okay, so we have the joint plot. We say the kind here is we are specifying the scatter. So the way you use the joint plot, as soon as the joint plot, x-axis, what do you want to be on the x-axis? Is total bill. That is the total bill column. I want the total bill column to be on the x-axis, and then I want the tip to be on the y-axis. So this is the total bill column. This is the total bill column on the x-axis and the tip on the y-axis. All right, so that's then your data. What's the name of your data set? Tips, and what kind of plot do you want to plot? Scatter. All right, so that's the way to use the joint plot. We also have the kernel density estimator. It's also a kind of plot, still the same joint plot, but different ways of presenting them. All right, so we have the pair plot. What the pair plot does is it plots every single. So this plot is it's very, very good, because you can use it to, at a glance, you can plot different numerical fields together. In fact, it plots everything within your data sets. All right, so the pair plots, what it does is that it takes every single combination, the tips, the total bill, and the size, every single numeric combination in your data set. Let me go back to data set. So we have the numeric combinations are the total bill, tip, and size. It takes every single combination and plots them against one another. Let me show you what it looks like here. So you can see here that this is the total bill, right? Let me use the last plots. This is the size. It's plotting size against total bill, tip, and size. It's plotting tip against total bill, tip, and size. So it's taking each of those columns and plotting them against other columns. So at a glance, you're seeing the pair plots. That is, you're seeing the relationship between each of those plots at a glance. You don't have to even start plotting them one after the other. So you have the size plot. You're saying okay, total bill and size. See that there is no much you can't really tell the relationship. The relationship is just so diagonally spread. It's looking very, it's not looking so diagonally spread. I mean, it's not looking, yeah, diagonal. It's just the total bill and tip. This is the one that is really looking as if there is a relationship between the two of them. All right, so we also have when you're plotting the pair plot, you can use categories now as hue. That is, you can decide to say, okay, I want to check the relationship between total bill and size with respect to the time of the time at which the customers ate their meal. The relationship between total bill and size, or let's say total bill and tip, with respect to the time they ate their meal. So you can also use a pair plot to show that relationship. When you do that, in this case, you're setting the hue as time. The time column is the one that is showing whether they are they ate during the lunch or during the dinner. Now you can see that here it's telling you that looking at total bill and tip, you can see that we have more people eating during dinner. From our table, you might not really tell. You can't see it from our table, but with this graph, with this visualization, you're able to see that, okay, the people that ate during dinner are actually more. If you look at them, you have more of yellow than blue. And then the people that ate during dinner actually gave more tips compared to, I mean, they had a higher bill and then they gave more tips. Like the person that gave this $10 actually ate at dinner. The person that gave around maybe $9 ate at dinner as well. So the people that actually eating lunch, maybe they didn't spend so much. You see them scattered, be around this axis. So when you're doing machine learning and then maybe you're trying to predict when people would actually eat, maybe you're trying to predict when you can predict that, okay, can I actually predict when people actually come to eat? And those people that come to eat at that time, how can I predict if they are higher spending people, or maybe they are just the middle budget people? With this relationship, you can actually, even without using machine learning, you can quickly say that, oh, it's likely people that actually eat during dinner are going to spend more money. So let me kind of adjust my prices, and it helps you to make some intelligent decision even by doing visualization. But the beauty about machine learning is that you are using modeling, like the models are able to learn the relationship, and then it's able to tell you within a statistical range that for sure so person is going to come and eat at dinner. So that's what machine learning does. Machine learning gives a more it gives you more leverage in terms of prediction. But when you're doing visualization, it tells a story. It tells you what is not obvious when you're just looking at your raw data. So that's what the descriptive analysis does. All right. So moving forward, I think I've spent some time on this pair plot. We have other plots too. You could use the day also as an EU here, Thursday, Friday, Saturday, Sunday. You can see that from this plot, looking at total bill and size, because the relationship is, the categories are too much, you can't really tell the difference here. So there are other plots that can actually show you some little clearer visualization, and that's the bar plot. Excuse me, we have the bar plots, we have the box plots, the whisker plot. So I'm going to start from the bar plot. Now, when you're using a bar plot, it shows you relationship between a categorical feature and a numerical feature. I've explained what a categorical feature is. As categories are like maybe male, female, high, low, medium, good, bad, such categories. Then the numerical columns are columns that have like a long range of value, maybe 0 to 100, scattered around, different ranges. All right. So now here you can plot a bar plot, checking the relationship between sex and total bill. Here you can now see that, oh, males actually tend to spend more compared to females, right? That's what this graph is telling us. All right. You can also do some more bar plots again with using different other relationships. Knowing that, okay, I'm just going to check use a categorical column with a numerical column. So you can say, let me use a bar plot with our smokers, right? Let me just so here I just want to check, this is bar plot and total bill. Here I want to check the relationship between bar plot and smokers. Now you can see that the people that actually smoke, they spend more when it comes to food compared to the people that do not smoke. So, this was not obvious when we're just looking at the tabular data. But because we are plotting graphs, so like it's showing us some key relationships between our data sets. All right. Okay, so moving forward, we could also do a count plot. When you want to use a count plot, you're using a frequency, like you want to do a frequency between your data. You want to see how many people are actually, what's the distribution between a particular categorical feature. That's when you use a count plot. All right. So you can have the count plot on the number of the smokers. You want to know how many smokers compared to how many people that do not smoke. So here, with the count plot, you can see that we have more people that do not smoke compared to people that smoke. But here, I'm not saying here that even those people that don't smoke, we have more of them spending money on food compared to the people that do not smoke. So you can see that this is helping us to, it's showing giving us some insights about that particular table. All right. So the box plots, what do the box plots do? You can use them between qualitative data, that is data sets that like you having a relationship between a categorical and a numerical feature. And what the box and whisker plots, does is that it plots after plotting, like here we are plotting the day that they ate their food compared to the bills spent. You can see that the lower bound here is telling you that this is the lowest value in that bill among the people that ate on Thursday. The lowest amount that the person spent was like maybe around 8. The highest money that they spent here is aggregated to 30, but then we have some outliers. Outliers are values that are out of range. Like this is the normal range of data sets within this Thursday people, the people that ate on Thursday. But then maybe there could be other values that are that are not within this particular distribution, and those are the outliers. So we have like 40, we have 45, which are outliers. But most of this is the this is the this is the this is not the maximum we have, but within that distribution, this is the maximum. Then we have the 25th percentile, that is 25% of the people within this distribution, their total bill is around, like, let's say maybe this is like 12. Then the median value, this line tells us the median value. The median value is around 15. The median value is 50% percentile. Then we have the 75% percentile, which is around 20. So that's 75. When I say percentile, like 75%, right, of the people that ate on Thursday spent $20. Okay. So that's the way to read the box and the whisker plot. So it shows you like the distribution of that data set. And additionally, it tells you the size. You can see that most persons are within this range of 12 to 20. So this box and whisker plot tells a story about different days of the week. You can see that most people actually ate the biggest, most people ate within on Saturday. If you look at, okay, which box looks bigger between Saturday and Sunday, I think they're almost the same thing. So you can say with this box and whisker plot, you can tell that, okay, most people are actually eating on Saturday and Sunday. The people that attended at the maybe that visit the restaurant, they eat on Saturdays and Sunday, which is reasonable. Find out that most people would always hang out on Saturday and Sundays, or maybe from Fridays, right? They would always go to work Monday to Friday, right? So this box and whisker tells you both the size and the distribution of the data. So you can see that the people that actually ate more are the people on Saturday, because of you can see the big range. We have the people that eat more on Saturday, and the people that actually spent most, where they spent more money on Sunday. You see that you're telling a lot of story with this analysis, right? So when you're writing your report, you're able to give a lot of insight. Okay, based on your data, we have that on that restaurant data, we have more people coming to that restaurant on Saturday and Sunday. And then if you now want to further know who are those people, you can now set your hue with your hue, right, it tells you more details, gives you more detail about the data. Here, you can see that the hue here, when we set the hue to smokers, you can see that you have those people aggregated within the Saturday and Sunday. You can see that most of them are smokers. It's interesting. Most of them are actually smokers because blue is smoker. We have blue as smokers and green as non-smokers. So the people that are eating on Saturdays, they are actually smokers. So that tells you what kind of adverts do I need to, how do I actually do personalized marketing towards these people? I know that there are smokers, more smokers come to eat at my restaurant. You can see how big the size is. It's so wide compared to this place, this ones. With this plot alone, you might not really see that because I was almost saying this that both of them are the same thing, but this is showing me an obvious difference that, okay, most of these people that eat on Saturday and Sundays are actually smokers. And then we even have them, they pay so much. They are our highest customers in the eatery. We have those people are actually our highest customers. I mean, they are a high profile customers, so we need to pay more attention to them. So that gives the company how well to target their maybe their marketing, when probably how well to design their marketing strategies. Maybe on Saturday and Sunday they can do so many promos around smoking and and all of that, so as to attract more people, because they know that those are the kind of people that come there on Saturday and Sunday. So on Thursday and Fridays they do another kind of adverts to the set of people. So you can further, you can compare uh, your total bill the day of the week, and then you can even compare it with another, let me see, you can even compare it with the dinner, yeah, the time, right? You can use the time also as well. Let me plot that. Let's see the relationship. Okay, I was trying to admit somebody. Okay, let's just do that quickly. So once you know how to, plot your graphs, and then you know how to interpret, right? It helps you a lot when you're doing your reporting time. So when you do this, you can see here. So in the process of plotting, there are so many other things. You can add your title, all those ones, you can read them up. You can add your title, PLT, the title. You can add, label your axis. You can set, like this one that is on this place, you can reset it using, there are so many. That's why the documentation is there. It gives you other ways to manipulate your you can set themes. You can, if you read it up, you see the examples as well, how to use it, how to use to plot different type of graphs and all. So I'm just showing you like the basic use case of this. So you can see that here you can see that the relationship between lunch and dinner on Thursday. This is another story, right? People are actually eating lunch on Thursday. On Friday, they ate lunch. They ate more of dinner on Friday compared to lunch. On Saturday, no lunch at all. So the people that actually, these guys here, these guys here, where are the guys here? The smokers and the non-smokers, they actually came for dinner, not lunch. See, nobody came for lunch. They came for dinner. So that tells you that, oh, okay, these people that are actually coming, the smokers, they are not even coming for lunch. So our marketing now should be more strategic towards the dinner meal, right? Not lunch. So if you're just staying on the previous insights, you might miss out on some specific details. That's why as a data scientist or data analyst, you tend to like, you think outside the box, you do a lot of analysis, you do so many analysis just to try to find out information about your data set. This you're still, you're still doing descriptive analysis. You're not even predicting yet. You're not doing machine learning. So without machine learning, you're already doing a lot. You're seeing a lot of relationships. It's telling you a lot of stories. All right. So I believe that you're getting the idea behind visualization. So once you understand these basics, for other visualization tools, right, it's just to learn how to write the syntax. And once you understand the syntax, you're able to, the most important thing is how to interpret your results, because that would aid your storytelling. If you're able to interpret your result very well, you can, tell different stories with your results. And then, you can propose solutions to whosoever needs it. We also have the volume plot. It's still the same thing. It tells you it's just another way of showing your results. It tells you the same story. This tells you the size of the orange. This is like an orange. This is another orange. This is just showing you that, okay, this is like is plotting the distribution of the data. When you look at Thursday, on Thursday, it's telling you that we have more person. The bigger the orange, the more the people aggregated towards that day. So this is Thursday, which I think they all look the same. Let's look at our violin plot for total bill with introducing hue. When you introduce hue, now you can see that the orange is looking different. You can see here that more females eat on Friday compared to males. So the people that are actually eating on these days here are females. You can tell that, okay, the people that are actually eating here are actually female. But let's look at Saturday and Sunday, because Saturday and Sunday looks interesting, right? Saturday and Sunday, this tells us, okay, there's a kind of equal, most of them are male and female, right? Okay, so we can look at the swamp plot, the strip plot too. The strip plot too is telling you, this is just showing you the size. You can see that more people are eating on Saturday and Sunday compared to other days. Okay, here, if you look at this one plot, here is day against total bill, right? Same thing, you can see the relationship between the 2 days. All right, so it's still the same plot, but different ways of visualizing them. All right, so I'm going to stop here because I've spent so much time on Seaborn. Let's go through our project so that we can have some time for questions.